Hello, students. Today we are going to see this topic algorithm for searching techniques. Okay, so these searching. Okay, before going into the topic, we'll just see what is meant by searching. So, in a group of data, okay, there will be some group of data. It will be having some index or it will be having some address. Okay, so that address will be uh, finding that address of that data is the aim. Okay, so finding of the address for the particular data is our objective. So you have the given data will be the data will be given to you. You will be searching all the elements. Okay, all the datas in the group of data. Okay, so this is known as searching. Okay, so searching means there will be a bunch of data, and then you will be given data. You will be searching all the data, and you have to find the address of it. Okay, so this is the objective of searching. So there are some algorithms which are being created or which have been implemented long back. Okay, so they find that these algorithms are more effective than others. Okay, so in this topic we are going to see two types of search algorithms. One is linear search and another one is yes, another one is binary search. Okay, so linear search, first of all we'll see what is linear search. So linear search is also called sequential search, is a sequential method of finding a particular value in a list. This method checks the search element with each element in the sequence until the desired element is found or the list is exhausted. In the search algorithm, list cannot be need not to be ordered. Okay, so these are all the things that you have to keep in mind, that this method will move sequentially from top to bottom or bottom to top, and it when the searching data is found or searching elements is found, then it will display the result of it. Okay, or it will display the result like it is not found when it search all the data but does not found the result. Okay, does not found the data in the group of data. Okay, so this is the possible way of finding it. Okay, in this algorithm, and it can be either ordered or unordered. Okay, so ordered means starting from ascending order or descending order. Okay, so increasing order or decreasing order. So it may be of any order or it may be unordered. Okay, it doesn't have any order or it is shuffled. Okay, so pseudocode. So here they have given some pseudocodes. So pseudocodes means steps that has to be followed when you are using this linear search. So traverse the area, traverse the array using for loop. So traverse means accessing the element of the list or the accessing the data at least once is known as traversing, going through the number of data. Okay, uh, at least once is known as traversing. So in an array you'll be having more number of elements, and traversing means at least accessing the elements of array uh, at least for once. Okay, so this is known as traversing. So the first step is you are traversing through the array with a for loop. So the next step is In every iteration, compare the target key, compare the target search key value with the current value of the list. Okay, so you will be given some number, and you have to compare that given number with the list of the search. Okay, so if it is found, the next point you can see that if the value matches, display the current index and the value of array. If the value does not match, move on to the next array element. If no match is found, display the search element is not found. So here they have given one example. Here you can see that this is the array. Okay, so here you can see that 10, 12, 20, 25, 30 is the values or elements. Okay, here you can see that at the top of every element they have given some number. Okay, so 0, 1, 2, 3, 4, so that is index, so that is address. So here they'll be giving some number, so that you have to find it. Okay, to in the paragraph you can see that to search the number 25 in the array given below. Okay, so this is the array, so you have to find the value 25 in the value, okay, in the group of array. So linear search will go step by step in a sequential order, starting from the first element in the given array. If the search element is found in the index, then uh, it will return the index value. Otherwise, the search is continued till the last index of an array. In the example, in this example, number 25 is found in the index number 3. So here you can see that it will first start from 0. So 0, the 10, 10, the value is 10 is compared with 25, it's not found. Okay, so then it will move on to the next one. So in this the value is 12, so the 12 will be compared with 25. It is not equal to 25, then it is moving on to the next uh, element. Here you can see that it is 20, 20 is compared with 25, it's not equal, and then it is going to the next position. So 25 is equal to 25. Now the match is found, then it will access the index which is 3, and it will display the index and the value of it. Okay, so this is the program that is used to display the index of it. Okay, so this is a type of search. Now next we can see that this is another type of search. Okay, so binary search is also called half interval search algorithm. So it will this is another type of search technique. So it is also called as half interval search. It finds the position of the search element within a sorted array. If you have to, in the previous one it may be of any order, but here in the binary search it must be ordered either in descending order or in ascending order. So the binary search can also be done as divide and conquer search algorithm. So it does this searching process by dividing and conquering it. Okay, so we'll see the pseudocode of binary search here. Start with the middle element. Okay, so it will divide the entire list of arrays. Okay, list of elements into two. Okay, so by finding the middle element. So how it finds the middle element? If the if the search element is equal to the middle middle of the array, that is the middle equal to number of elements in the array divided by 2, then return the index of the middle element. If not, then compare the middle element with the search value. If the search value is greater, if the search value is greater than the number in the middle index, then select the elements to the right of the index, middle index. Now go to the step 1 again, and if the if the search element is less than the middle less than the number in the middle index, then select the elements to the left side of the middle index and start the step 1 again. When the match is found, uh, so it will do this 4 steps repeatedly again and again. When a match is found, display the success message with the index of element matched. If no match is found for all comparison, then display the unsuccessful message. So here they are given one example. So list of elements is an array must be sorted first for binary search. Okay, so here you can see that this is the example. It is sorted in increasing order. Okay, from lower element to higher element. Okay, increasing order. So the following example describe the step-by-step operation of binary search. Consider the following array of elements. The array is being sorted, so it enables to do the binary search algorithm. Let us assume that the search element is 60, and we need to search the location or index of the search element 60 by using binary search. Okay, so the element which you want to search is 60. You have to find the uh, index of the element 60. Okay, so you can see that the first step is to find the midterm of it. Okay, middle element of it. Okay, so we find index of middle element of the array by using the formula mid is equal to low plus high minus low divided by 2. Here it is 0 plus 9 minus 0 the whole divided by 2, which is equal to 4. So it comes around 4.5. So the fractional part is ignored. So the middle element is 4 here. Okay, so now the search element is 60 and the middle element is 50. Okay, so you can see that 60 is greater than 50, so it will move on to the right side of it. Okay, so right side, since the array is sorted, it will move on to the right side of the middle element. Okay, so if the given element or the search key element is less than the middle element, then it will move to the left side of it. Okay, so now you can see that it is moving on to the right side of it. Now it calculates the midterm again. Okay, now compare the search element with the value stored at the mid value located at the 4. The value stored at the location or index 4 is 50, which is not matched with the search element. As the search value 60 is greater than 50, now you can see that it is eliminating the values after 4. Okay, so starting from 0 1 2 3 4 is eliminated. 5 6 7 8 9 is alone considered. Okay, so you can see that now the value of low is changed from 0 to 5. So how you get the 5 means mid value, last mid value is 4. 4 plus 1 5. Okay, now it calculates the mid again. So mid is equal to low, which is 5 here. 5 plus 9. 9 minus 9 minus 5 is 4. The whole divided by 2. You can see that the answer is 7. So this is the formula. So 5 plus 9 minus 5 divided by 2 is 7. So you can see that the midterm is 7 here. Now the middle term contains the data of 80. Okay, now it compares the 60 with the 80. You can see that 60 is less than 80, so it move to the left side of the middle term. Now you can see that the higher value is getting changed. Okay, so the value stored at the location or index 7 is not matched with the search element, rather it is more than what we are looking for. So the search element must be in the lower part from the current middle value location. So the search element still not found, hence the calculate the middle term. Okay, so now it will eliminate the 8 and 9th element, since it is having greater value than the middle value. Now it will take into consideration only the 60, 70, fifth element, sixth element, and seventh element. Okay, now the high value gets changed by mid minus 1. So the older mid is 7. So 7 minus 1 is 6. Now the high value is 6 and the low value is the same. So the low value is 5 now. 5 minus low value is 5 plus high is 6. 6 minus 5 is 1. 5. So calculating this formula in the calculator, you can see that it will get the value as 5. And now you can see that uh, the mid value is 5, and now it compares the 5 element with the given number. It gets the, now we compare the value stored at location 5 with our search value. We have found that it is matched. Okay, now we can see that this will display the, we can conclude that the search element 60 is found at the location or index 5. So for example, we are taking the search element as 95, which is not in the binary search. The result will be shown as unsuccessful result. Okay, so this is a way of searching an algorithm. Okay, searching data in the given group of data. So today we have seen uh, two types of two types of searching algorithm. One is linear search and the next one is binary search. Okay, so this binary search is an important 5 mark question. Either it can be asked to display only the pseudocodes. Okay, write only the pseudocode of binary search. Okay, or they will be giving some a list of elements in that. You have to find it by using this steps. Okay, and you have to explain the steps. Okay, so these are all the important 5 marks, and it may be asked in any way. Okay, so either 3 mark or 5 mark, they may be asking this binary search. So take some time to read this binary search. It's a very important question. Okay, so with this we'll finish the class. We'll see the sorting techniques. Okay, next is sorting. Sorting means arranging. Okay, so arranging the elements with a particular algorithm. Okay, so there are so many algorithms there. We'll see one by one. So with this, we'll finish the class. We'll see the rest of the things in the next class. Thank you, students.